Well, hello guys, here Mr. G with another question. This time we're going to be answering question 5 from June 2023 done at the Northern Cape. It's a question on universal law, and it's quite important because it was a very similar question in the grade 12 as well. So it is very applicable for the grade 11 and 12. This question said a 700 kilogram satellite orbits the Earth at a radius of 8 meters. The gravitational force exerted on the satellite by the Earth is 6,500 Newton. Question 5.1 state Newton's universal law in words. Now, Newton's law of universal gravitation states that every particle in the universe attracts every other particle with a force that is directly proportional. That force is directly proportional to the product of the masses. That is the first mark you're going to get, guys. So if you do that, you'll get 1 mark, okay? And the second mark is for saying that that force is inversely proportional to the square of the distance between the centers. That is the second mark. And please, the important thing, I've seen very good learners forgetting the word square and losing 1 mark. Be careful with that one. Calculate the distance h from the satellite to the surface of the Earth. So to do this question, let's see the data we have. So what we have, let's find out and write it on this side here. We have that the mass of the satellite is equal to 700 kilograms. We have that the gravitational force between the Earth and the satellite is going to be equal to 6,500 Newton, right? We are looking for, let's say, h. That is what the question is asking. But know that the h is only the distance from the surface of the Earth, from here, this surface of the Earth, to the center of that satellite, okay? So if we come to this table that is given to you guys, you can see that we have certain data available for this specific topic. So my humble advice is go there. We have here the universal gravitation constant that is needed for this question, guys. There we have the mass of the Earth, which is very much needed for this question, and there is the radius of the Earth. All those data are very much needed. We are going to copy that data here, but you don't have to rewrite it, it's just there. So the mass of the Earth is equal to 5,98 times 10 to the 24 kilograms. We have that the radius of the Earth, and I'm going to speak just about the radius of the Earth, is 6,38 times 10 to the 6 meters. And the last data we have here is that capital G, which is the universal gravitational constant, is equal to 6,67 times 10 to the minus 11 Newton per meter square, or Newton meter square per kilogram square. Okay, so this is the data we have. We're looking for h. All right, now this radius, which is what I said I'm going to speak just now, of the Earth, this radius of the Earth is the distance from the surface of the Earth to the center of the Earth. This one here, guys, is what we have, radius of the Earth, which is the data given to us there. So what we have to do, we're going to use the universal law formula, which if we go into the formula, it is just here. Here is the universal law that we can use. It's the same formula with a different symbol. Please don't get confused. It's the same formula. It's the very much same formula. So let's do it on this side here on the right. It is more than enough space. So the formula is gravitational force is equal to G, which is the constant mass of the satellite, mass of the Earth, divided by the distance. I'm going to write distance square, and I want you to note the following. This distance we are talking here is going, what is that? So that distance there is going to be the distance from the center of the satellite to the center of the Earth, which in other words is this distance here, guys, and is going to be the distance is going to be equal to h plus the radius of the Earth, and this h is what we are looking for. So this distance is the distance that we are looking for. That is quite simple, and it's important to notice that. Okay, so now when we do the substitution, let's substitute before rearranging. Why? Because you get the mark for substitution. So let's substitute and then rearrange. We have that the gravitational force is 6,500. Be careful when you substituting. People attempt to make mistake. This one is 6,67 times 10 to the minus 11 times the mass of the satellite is 700 times the mass of the Earth is 5,98 times 10 to the 24. Make sure it is that one, or yes, then divided by the distance. Remember, this is the whole distance square. When you rearrange this one, now I am going to rearrange. Distance square is equal to 6,67 times 10 to the minus 11 times 700 times 5,98 times 10 to the 24 divided by 6,500. There we go. Now do all the substitution and then straight find the square root. Remember, because you have a square here, you have to determine the square root on both sides. This is simple math. I'm not going to go into that detail, but when you do this calculation, you should get the answer as, then the answer is 6,5. Let me write it. I'm writing from the calculator. 553,991. 553,991,15 meters. Remember, this distance is not the one they want. They want h, and then you know from here, from this part on top that we just spoke about, this one there, that h will be the distance minus the radius of the Earth. So let's do that. The height that they want is equal to the distance minus the radius of the Earth, and when you substitute, the distance is 6,53991,15 minus then the radius of the Earth is given to us. Let's just quickly move this one a little bit because it is right there and it's not going to be enough space. There we go. So now we can go there, minus the radius of the Earth, which is 6,38, is 8, not a 6, 8 times 10 to the 6. Then the height that you're looking for is equal to 17,173,000. That is the answer. 991,15 meters. That is the height at which the satellite is orbiting the Earth, guys, from the surface. I really don't think this topic is very bad, but anyway, that is the answer. I hope it helped. Now question 5.3, if the satellite is orbiting at a smaller radius than h, how will the gravitational force change compared to 6,500? Guys, if you decrease the distance, remember the gravitational force. Now all we're doing is going back to the law. There is the law. It is inversely proportional to the square of the distance. So force, we're going to write with symbol right here. Force of gravitation is inversely proportional to the square of the distance. I'm going to write d square because we use the symbol of d, the square of the distance. Therefore, the answer is going to be smaller than. If you decrease the distance, it's going to be greater than. If you decrease the distance, then the force increases. Greater than. Give a reason for your answer. The magnitude of the gravitational force is inversely proportional to the square of the distance. Guys, this is the end of the story. Very simple question, and it's a very good question as well for the grade 11, but not just grade 11, it's a good question for grade 12 as well. But thank you for watching. I hope it helped. If it did help, subscribe for the channel, thumb up, write comments, write messages, and I'll see you next time. Mr. G here.